Okay, we're going to talk today about permutations without repetition. So first of all, let's talk about what permutations are. When you think of permutations, what you're going to want to say is these are combinations. I'm going to tell you flat out, you cannot say combination. So it's going to be something you want to say. You cannot say that because combinations are something different altogether, Matt. It's very much related. We're going to talk about combinations later. But permutations, okay? Permutations is pretty much how many different orders can you put things in? How many different orders, okay? And with permutations, we're going to talk about two distinctly different things, okay? And that's with repetition and without. Um, Now, when you think with repetition, if I said, hey, your PIN number, right? PIN, right? We shouldn't have to actually say personal identification number. So when you say PIN number, it's actually your personal identification number. Silly. But PIN number is typically 4 digits, right? It can be up to 6, but it's 4 digit number, right? And you use it at the bank, right? You swipe your card, okay? And you could say, hey, I have a first slot, a second slot, a third slot, and a fourth slot, okay? And pretty much what you have is you have 10 numbers to choose for the first one, right? You have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? You have the 10 single digits. So you have 10 here, 10 here, 10 here, and 10 here, right? So all you'd say is I have 10 to the fourth power, and what does that mean? That you have 10,000 different pins that you could make, okay? Now, without repetition would say something like this. Um, um, you can't use the same number twice, right? So that becomes a different thing, okay? So if I said, say for example, you're running a race, right? You have 4 people racing, right? How many different orders can they come in, right? If you have 4 people racing, somebody's coming first, somebody's coming second, somebody's coming third, somebody's coming in fourth. Well, again, you have 4 slots, and let's think about this. How many different people can finish first is 4. But once someone's finished first, they can't also finish second. So you only have 3 people left to finish second. Once you have that, 2 people and 1. So what does this become? 4 times 3 times 2 times 1. So you can't there's no repetition. You can't come in first place and second place. You can't come in second place and fourth place. And this is what we talked about, and this would be 4 factorial, right? Which we said the other day was 4 times 3 times 2 times 1. So 4 times 3 is 12, 12 times 2 is 24, 24 times 1 is 24. And I told you guys if you have a calculator, it's the exclamation point, so it's right here. So I gotta clear this. If I said what's 4 factorial, it will tell me that it's 24. On Desmos, if you guys are on Desmos, I'm gonna keep that open. Desmos. Oh, my wife is calling. Okay, sorry about that. If you don't have a calculator at home, you don't want to use your phone. If you go to Desmos, just type in Desmos Scientific, and you can have a calculator, and it's under the function. So if I said 4 function, and you're looking for the exclamation point, you can also just type it on your keyboard. So if I said 4, and then I type in Shift and 1, it will tell me that it's 24. Okay. So let's take a look at some of the questions you might be asked. They're really pretty straightforward. We are only going to be talking about without repetition problems today, okay? So I'm not a huge fan of IXL because they just lump these as permutations and they don't talk about repetition, not repetition, but another day, okay? So again, a restaurateur is planning a new menu. If 4 appetizers are offered, how many different orders can they be listed on the menu? Again, you're gonna have 4 for the first one, right? 4, I can't write on the screen, hold on. You're gonna have, right, 4 for the first slot, then 3, then 2, then 1. So this would be 4 factorial. So 4 factorial we already know is 24. Okay. It says Laura and her friends are trying a new restaurant together. They've ordered Salisbury steak, barbecue chicken, beef stroganoff. Oh, love beef stroganoff. Beef brisket and citrus salmon. No vegetarian orders. All right. If the dishes will all arrive separately, and how many different orders could a dishes arrive? Well, you got Salisbury steak, barbecue chicken, 3, 4, 5 different dishes here, right? So again, same thing. One comes first, then there's 4 left to come second, and 3 left to come third, and 2 left and 1 left. So 5 times 4 times 3 times 2 times 1. So again, 5 times 4 is 20. 3 times 2 is 6. 1 is just times 1, doesn't really matter. And 20 times 6 is 120. So there's 120 different orders. And you'll see these numbers get really big really fast. So again, if you have a calculator handy, you just go and you type in 5 factorial, right? 5 dishes. How many ways can they come out? So you go out there, you go wham, you break out your calculator, you say 5 factorial, and it will tell you that it's 120. I hope you guys can hear that bird screeching in the background, by the way. All right. So again, well, you gotta get 120 different orders over there. All right, so Alice and Logan are playing hide and seek and taking turns being it. How many different orders could the children take turns being it? Well, I hate to say it, but hide and seek with 2 people is pretty, that's a rough one, I tell you. So that's just 2 people, right? And then 2 factorial is 2 times 1, which is just 2, right? In other words, Alice, then Logan, that's one way, right? Or Logan, then Alice, right? That's the other way. There's only 2 different ways that this can happen, okay? But you guys would be surprised. The faster this, the bigger these numbers get, they will grow just huge numbers very quick, to the point that if you have something like 10 factorial, it's just such a gigantic number, okay? Julia's raising chickens in a backyard coop. If she's expecting 4 new chicks to hatch, and how many different orders can they hatch their eggs? Again, 4 factorial. Let's skip up levels. See what we got. Oh, we're entering the challenge zone. Oh God. Okay, so same question. So pretty much what you're looking for is there's going to be no repetition. Two new eggs to hatch. 2 different orders, right? Adele. Oh, it's Adele. She sings songs about love and loss. She's opening her own rrestaurant, and she needs to design the menus. If the entrees will be offered are blackened tilapia, beef brisket, meatloaf, and chicken fingers. Again, no vegetarian option. And how many different orders could they be listed? What do you got? You got 4 dishes, 4 factorial. What do we say? That's going to be 24, right? So again, there's only so many numbers they can ask you, because there's only so many numbers you can get, okay? A town events committee is planning a talent show with 9 local performers. And how many different orders can the committees be arranged? And how many different orders can the committee arrange these at? So again, so 9 factorial. 9 factorial, you're going to see, turns into a very big number very, very quick. So again, you break out your calculator, you say, hey, what is 9 factorial? And you find out that there's 362,880 different ways, okay? So again, these numbers get real big real fast. And you wouldn't think that, right? That's only 9 different musical acts, and you could erase them 362,880 different ways. Like, wow, that's a lot for just 9 different acts, all right? So think about that. You got your 9 favorite acts, right? You got whoever you like out there. And if you were having an all-star concert, how many different ways could you organize them? Insanely enough, there's 362,880 different ways you can just arrange those 9 groups. And I know that sounds crazy, but that is true. Okay, you can try it sometimes if you have a ton of free time on your hands to write out 362,000 different ways. Okay, so I'll find you guys some more complicated ones for Monday, and we'll talk about it more on Tuesday. Thanks, guys. Bye.